Okay, so this is our first problem in constructing an influence line after today's initial lecture. So I want the influence line for the reaction at B. So there it is. So the technique that we've learned so far is to solve for that reaction. In this case, BY. We'd also have reactions at AY. We may not need that. And just to be complete, there would be a reaction in the X direction. So where's our influence line? Well, let's just say this is our unit load, 1, and it's located at distance x from the left-hand side. Can I solve for the reaction at B for this load scenario? Yes, of course. And how would I do that? Yeah, if you sum moments at A and make sure the structure is in equilibrium, what do we get? So what is the moment created by the unit load about A? Is it positive or negative with my sign convention? Negative. So it'd be -1. The moment arm is x, and then BY creates positive moment about A, and its moment arm is 5 feet. So solve for BY. And what do you get? Looks like you get x divided by 5, right? I don't think that's hard to plot, so let's plot that. So the ordinate of my graph, remember now, is BY. So I'm tracking the value of BY as the unit load varies across the structure. And I'll go ahead and just put some lines down to give you some space. So what is the value when x is equal to 0? It's 0. What is the value when x is equal to 5? It's 1. And then at x equal to 10, it's 2. So that's a linear line with a value of 2 and 1. And that's it.
Could you go over that one more time?
Which part?
Drawing actually.
I just plotted this function.
Okay.
Right? So I put in x equal to 0 and I got 0.
Right.
Now it's linear, so I could go all the way to the other end and just put in x equal to 10 and I'd get 2 and just connect the dots.
Okay.
But I wanted to show you that when the unit load is right over BY, BY is equal to 1. You guys see that? That's it. So while we're here, let's do another one. What about AY? How would I find the influence line for AY? Let's assume that we don't have BY at all. Yeah, I could sum force. Well, there's two ways. I could sum moments now at B and solve for AY, or knowing BY, I could sum forces in the Y direction. Let's do it the other way first. Let's sum moments about B. So summing moments about B, what do we have? Well, you're going to have to get a little bit of something different here. What is this little distance right here?
5 minus x.
5 minus x. So now when I sum moments about B, this unit load creates positive moment with the moment arm of 5 minus x. And then I have AY creating negative moment times a moment arm of 5. So when I solve for AY, looks like I get 5 minus x divided by 5 is 1 minus x over 5. Does that look right?
Yeah.
So let's plot that. So I'll do same midpoint, endpoint. So when x is equal to 0, what do I get? 1. When x is equal to 5, what do I get? 0. When x is equal to 10, what do I get? See that? So actually, when my unit load gets all the way out here on the end, what's my reaction at A? -1, which means it's negative, which means it's not up, it's down. Does that make sense? Yeah, because I'm all the way out here on the end, this beam is kind of seesawing, right? Now here's something cool. What is AY plus BY equal to? Well, what does it say they have to be equal to for equilibrium? 1. Are they equal to 1? At every point on these two graphs, if you add them together, what do you get? You get 1.
They don't have to be equal to 1.
Well, for equilibrium, they have to be, right? If I sum forces in the y direction, looking at my free body diagram, it says that AY plus BY minus 1 has to be 0, which says that. And if you check our two curves, they also match that. So this is a starter problem. Will you ever see something this simple in the exam? No. Of course not, but this is just a starter problem. So any questions about that one? We'll do some more. Okay, then we'll stop.